So just a bit of a warning that this talk is not part of your training. It has not been approved by US EPA. And I used to be a data producer, but now I'm a data user. So it's purely from a perspective of a data user. So you could feel free to ignore everything I say, and especially if you've seen this before, you could really ignore everything I have to say. And I understand QA/QC. I was, for a short time, in charge of the QA department at South Coast. So in principle, QA/QC needs to be blind, needs to be independent, assure the highest quality of all validated and certified data, regardless of how it's going to be used. You shouldn't necessarily be thinking about the implications of a particular QA decision, whether you're validating or invalidating a data point, because you should be blind to that. You know, obviously you don't want to be biased. A lot of QA is about setting the rules of the game before you play the game, and then you don't deviate from those rules just because there's a big implication to a decision. And then again, ensure proper, complete documentation to support all data decisions. These are all very important things that should not be compromised. But if you need to be blind to this, why do you even need to talk about the big picture? Why do you even need to know if you're a QA manager or working in QA, you shouldn't even. Again, you need to be blind to some of these issues, but there are some things to keep in mind as you're going about doing your job that are very important. First of all, even though all data should be validated, all data or invalidated, every data should be looked at, but not all data is created equal. Obviously, some areas are still in non-attainment for PM 2.5 or ozone or even lead, and when you're in non-attainment, that data is by definition, a lot more important, especially if you're getting close to attainment, non-attainment borderline. So criteria pollutants like PM and ozone might be more important than, say, SO2, where nowhere in California is in non-attainment, and the numbers are almost below detection levels. And then when you're working with air toxics, same thing. There's some air toxics that are very potent, that are have very high risk, that are on everyone's radar, and there's some that you hardly ever see. But then there's others that if you did see, then it does raise a flag, and there's others that have very high risk. So when you're doing your QA or you're trying to rescue a data point by searching back and trying to find all the documentation on that data point, it may be important to do so because eventually somebody's going to ask. And again, big picture, you know, we all have limited resources when it comes to doing this work, so you might want to think about where you want to allocate those resources in terms of doing, you know, research on a certain set of data or looking at different pollutants more carefully. Again, prioritization of those tasks, and even if you're meeting all your QA requirements, you might go above and beyond a little bit when it's really a very important issue, extra attention to detail, enhanced documentation, just in case that data point comes into question. Mike's analogy with the bill on Capitol Hill missed one point. Even if the president signs a law, the Supreme Court can overturn that. Even if you certify data, there could be a lawsuit down the road that could easily throw out that data as well. So it all ends up in the courts, and a lot of my time these days is about responding to court decisions when it comes to SIPs and other things. So again, the other part about big picture is the quality of the data is important, and you try to define your data quality objectives beforehand and all that, but the intended use of the data really dictates the level of quality. And obviously if it's an attainment decision for PM 2.5, ozone, and attainment, non-attainment, obviously has to meet every QA requirement, highest data quality. But there's others that, you may think, okay, there's a problem with this data point, I'm going to invalidate it. But there still may be some use. Maybe the error bars are higher. Maybe you invalidate it based on a technicality in a logbook or something. But somebody may still want that data point to look at various things, trends, design values, whatever it is. And preliminary data. Often people working with data are very reluctant to give up that preliminary data until it's gone through the final process. But you're going to get asked for it, and it's okay. You just need to caveat it and know that the people using it need to know that it hasn't been fully validated, it hasn't been certified yet. But again, you will get asked for that data if it is a high-profile issue. So here's just a few examples. A lot of these came from EPA, and these are examples of when what seems like maybe a minor QA thing or maybe a larger QA thing has really affected not only a big picture when it comes to attainment, non-attainment, but actually public health. So some of you may know this, that there was a lack of approved QAP in Arizona, and there was some data, this Mike corrected me in my last talk, I think it was for lead, and there was a lead monitor showing non-attainment with the standard, but they weren't able to use that data point because there was no approved QAP. So that had to go through the process, create a QAP for it. In retrospect, it took a long time, and then EPA can complete its designation process, non-attainment for lead. But in the meantime, you had several years that there was no designation and no work was being done to reduce the lead emissions. And if you've looked at some recent CFR language that's been inserted, now QA kind of has this weight of evidence type of test that a technicality like that shouldn't necessarily throw out a data point if the weight of evidence is such that it should be valid. And I think that's an important improvement, that we don't get caught up on these technicalities all the time. This is a little bit about QA. This comes close to home because it was our annual monitoring network plan, but we were the EPA was sued on their approval of our annual network plan because they thought that we didn't have enough near roadway monitors, and then we didn't have our max concentration site. This was all going on as EPA was requiring near roadway monitors, so it's just finally worked its way out. But for a long time, we were working in the courts to figure out whether maximum concentration site meant that you had to be next to a roadway. Again, now since we are required to do that, it's kind of a moot point. But again, the annual monitoring network plan there was a threat that it was actually going to overturn our SIP approval because we didn't have that annual monitoring network plan perhaps approved. Another one was this lab weigh room requirements. This was more of an issue nationally than in California, but there were a few lab weigh rooms across the country that were outside of spec for a certain period of time, and that data actually was invalidated, and EPA couldn't designate those areas, again, till 3 years of valid data was collected, even if we kind of knew that those areas should be attainment or non-attainment. And again, this is a delay towards designation, which is a delay towards a SIP, which is a delay towards actually doing something about reducing PM levels, which again has a big public health impact. If I had to do the calculation, you could probably actually attribute excess mortality to an action like this. Again, so attainment, non-attainment, and I'm not sure this has happened, but theoretically can happen, especially when you're talking about 24-hour design values. Attainment, non-attainment could rest on the validation or invalidation of a single data point. We may be in that situation in South Coast where we're so close to the 35 microgram per cubic meter and we're looking at the 98th percentile. I mean, could be 1 or 2 data points that would put us above or below that line, which has huge implications. And again, it could be a multi-billion-dollar decision. We've had rules in South Coast, say for SOCs, that have been calculated to be multi-billion-dollar rules that we would not have to pass if we were in attainment of the PM 2.5 standard. Then legal challenges, I mentioned a couple, but they're much more common. So the data must be fully defensible, which isn't always easy. And again, this lack of documentation, the lack of support for data causes delays and causes resources and costs money. Not to mention the increased staff resources it goes towards when you have to investigate these things. So again, there's, on your day-to-day work, looking at the quality of the data, looking at the data stream coming in, it seems like 99.9% of the data nobody's ever going to look at, and to be honest, that's probably true, but that 0.1%, and you don't know what that 0.1% becomes the most critical part of it. Okay, so if none of that scares you, I'm going to talk a little bit about an emerging issue that some of you have started to deal with, not all of you, and that's the emergence of these low-cost air quality sensors that are on the market now. Many of you have probably seen these online, and you can purchase them. There's all these here in this picture are now pretty much commercially available. Any one of you can buy one of these from anywhere from $50 to maybe $1,000, $2,000 at the high end. They're not used for regulatory purposes, obviously. None of these are FEMs or FRMs or certified methods yet, but they're going to be used out there, and they're going to be used by community groups, individuals, industry, everyone out there, because they're cheap, they're available, and they're pretty, and they have big numbers on them, and people, when they see a big number or a big color, they're going to assume it's correct. They're much slicker than the instruments we use. So you know all this, all the parameters that affect data quality in our traditional instruments. It's all the same for these instruments. The problem is these instruments have not been tested for all these things. Very few of them have been tested for these things. So that's the problem. So when at a district, if we're getting phone calls from a community group or an individual saying, oh my God, I have a air quality sensor and my ozone levels are at 300 ppb, what do I do? We have no idea what to say, because we can ask what sensor are you using, and we can't just say, oh, that one doesn't work, because maybe it does a little bit. So we need to have some information to help us answer those questions, and we don't really have that yet. The other piece of this is, remember, intended use of the data. So you might need, these things are going to need QA/QC when they are in use, whether we're using them or the community is using them. So you're going to need more flexible QA/QC, because in some cases, plus or minus 30%, plus or minus 50%. Maybe these are just yes/no indicators in certain studies that you're doing. So you need to have a flexible QA manual or a flexible QA plan to kind of handle these widely different types of uses and data quality objectives. Okay, they're not ready for regulatory purposes yet. I just saw some recent data that on a PM monitor that looked pretty good. It was a little scary how good it looked. So I think we're getting there. But even before it's an FEM, and it's probably a ways, but I wouldn't be surprised in 5 to 10 years that we had a FEM PM 2.5 monitor that was $1,000 or less. I bet on that at this point. You can use them for screening. You can use them for many different things. You can look at short-scale spatial variations in a neighborhood. You could help your network design by, testing out different sites for maximum value or similarity. Permitting, testing some of the modeling for permitting, fence line monitoring at some facilities, community monitoring. But again, a lot of QA challenges. There's a wide variety of applications. Another challenge is huge volumes of data. A lot of these connect second by second data, or at least minute by minute data. But it's not just that. They're cheap enough where they'll be deployed in networks of 10 or 20 or 50, all within the same neighborhood, perhaps. So how do you deal with that huge volume of data coming in? It's impossible to look at every single data point. So you're going to have, some clever software to do some validation, some visualization tools perhaps, but we need to develop some kind of procedures for that. New QA techniques and protocols for data management, different types of flags and caveats that could be put on the data. All this should probably be developed before it hits big time and starts causing us all a lot of grief. And again, it's not necessarily the future. It's already happening. These are on the market. We have community groups in South Coast and elsewhere that are already using these. And the technologies are improving rapidly. I've been involved. EPA's had a series of workshops over the past several years. I've been to, I think, pretty much every one of them. And the first one, you looked at the technology that was out there, and you're like, okay, well, don't have to worry about this yet. This is a long way off. But the last one, which was 3 years after the first one, there is dozens and dozens of these things that are getting data that is usable. Again, maybe not FEM quality yet, but definitely usable for certain purposes. And we can't just dismiss the data. When we get that phone call and somebody's asking, well, what does this say about my exposure and my air quality? We can't just say, oh, that's a low-cost sensor. Don't worry about it. It's not an FEM. That's not going to be acceptable in the real world. So again, we need to understand what that data means and the problems that data may have. The other thing is these are going to be great tools for us, because obviously we spend thousands of dollars per instrument. Right now they take weeks to deploy, and air-conditioned shelters, and tens of thousands of dollars to set up. If we could do that same work with a low-cost sensor that takes a few minutes to hang on a fence or something, runs on a battery, that's great for us, because we can make our jobs a lot easier. Again, QA/QC needs to keep pace. Right now, it's hard to keep pace because we don't have the information we need to even design a QA program or to do the data validation, because we don't understand the instruments. You need to understand each individual sensor or instrument. So you need better characterization. So there is a program in Europe. It's a little more formalized than what we have in the US. I could talk about that if anyone had questions. EPA has done some studies in their ORD and Office of Research and Development. Excuse me. And they've come up with some interesting results. And then South Coast, a little bit of a commercial here, not just a commercial, an invitation. Our board has recently allocated almost $1 million to set up an actual performance evaluation testing center for these sensors. Andrea just came. He's actually in charge of it. He's our QA manager. And we've already started testing some of these sensors. And the idea is that we're actually going to go out and purchase, because they're cheap, we can do this, commercially available sensors in triplicate or more, and run them through testing in the field, in the laboratory, under controlled conditions, and quickly publish what we find, and publicly. So we'll know, the public will know, community groups will know, EPA will know, everyone will know what we found in terms of our testing and the quality. We're not certifying anything, but we hope to maybe make some recommendations about what we think this might be good for or not good for. And then we can also provide feedback to the manufacturers to help them improve these sensors. So again, providing that guidance and clarity for this evolving technology, catalyzing the developers, and mostly to minimize confusion, because again, the assumption from somebody who buys these online is that it works. You spend $500 on something online, it has all these great claims, why would you doubt it? Again, what are we going to select? Commercially available is what we're starting with, although eventually we can get down to the sensor level instead of the package level. Potential near-term use, if we know that there's going to be a community study that's about to use these, we need to quickly understand what the results of that study are going to mean. Obviously, real time is more important. Criteria pollutants, there's some that might be able to do some air toxics. Again, the turnkey packages first. Again, not a certification program, field and laboratory testing. Part of it is developing our testing protocol. As we go, we'll be developing that. But also, we'll be looking at some potential QA/QC procedures for the data once we understand how these sensors work. We can categorize them, maybe make some recommendations, and the point is to put on our website like a clearinghouse for all information. We may have links to other studies on these sensors, or links to the developer, or links to universities who have also been doing some testing or use of them. So again, this is just in summary. We want to provide that knowledge so people can appropriately select, use, maintain, and interpret the data. Data interpretation is a big part of this too. Regardless of the quality of the data, obviously we know a lot about air quality data. We can interpret the data, but the average Joe on the street, when they see a number, what does that mean in terms of health? What does that mean in terms of the time averaging? There's a lot of things. So part of this is providing a forum where we can have a little bit of outreach to that community of users and talk about interpreting the data as well. Promoting responsible use of the sensors. Again, interacting with those local communities is a part of this as well, because if we can get them in up front before they start a community deployment, we can work with them, and eventually at the end, if it does point out some air quality problem, it's something we'll want to solve. Manufacturer feedback. And then the final thing here is this kind of an ultimate goal is once we have tested a lot of these, one idea is that we can actually purchase them in larger amounts if we think they work for certain purposes, and create almost a library where people in our area, it's like community groups or even individuals have a problem or a perceived problem, they can come and actually check out a sensor that's been calibrated, and we work with them. They could take it, deploy it, maybe individually, maybe in a study, and then get that data back, and we'll work with them on the interpretation of the data. But actually, it's almost like a library. We could check out a sensor like you check out a book. And that may be available to other districts as well in the state. So we don't have that yet, but probably a year or two from now, that's what we're working towards. We have a few proposals in to get some funding to do that. So just to conclude, that robust regulatory ambient air quality data is really the foundation of all these NAAQS decisions, the SIP decisions, the attainment, non-attainment decisions. So it really is the foundation for almost everything that we do. But you remember, these have multi-million-dollar price tags hinging on just a few data points in many cases. The the requirements for that collection and the QA need to be well defined, but we also need to evolve with the changing technology and also keeping in mind the big picture. And then the final thing is, we don't have a ton of examples, but it's theoretically possible that using poor air quality data or something being invalidated or validated based on a QA reason can actually have health impacts. If you're delaying a designation or delaying an attainment, or you have attainment when it really should be non-attainment, you can actually have health impacts because you have legal delays, you have these undetected exposures perhaps, and you have delays in bringing certain areas into attainment if you have these challenges. So there can be health impacts to QA on air quality data. So with that, I'll conclude and hope to answer any questions you have on anything I present or anything else.
Thank you. If they're receptive to it or more reluctant because of their hesitation that it's government that's running.
Well, that's what we're always fighting, right? They want to do it themselves. They don't trust us in many cases, but we think they should trust us. So one way, this is an outreach tool for that. Most community groups like this idea. There's a couple that weren't on our proposal that didn't like the idea, but we have community groups on our proposal. If it gets funded, they'll be part of that, and then we'll be open to many other community groups that aren't even on the proposal. So they've been receptive. In Southern California, and this may be the case all over California, the community groups who do monitoring are actually quite sophisticated. They work with universities. They have people on board that actually can run instruments in many cases or can interpret data, not in all cases. In other parts of the country, it's not always the case. So, but still, just to have that resource is important, and to have that communication is important. Any other questions? Yes.
I like the idea, but from a manufacturer's viewpoint, have you looked at the liability issues? Suits for saying their stuff is crap. Also, they can use you as research and development now.
Right, and on the last point, that's fine. I think we haven't worked out the payment, the full long-term support for the center yet, but it is possible that if you're developing a sensor and you want us to test it, pay a fee, and we'll test it for you, and that's fine, assuming we have the time to do that. And there's other ways we can work it. Liability, in EPA's programs that doing this testing, they actually worked with the manufacturers and got the instruments on loan and tested them out. And I don't think there were too many issues, but they had to sign some things, and when they issued their reports, obviously the manufacturers didn't want them pointing out that it had poor performance, and I think there were a few issues there. We're not necessarily working with the manufacturers, we'll just buy it. If we buy it and test it and put the data up there, I don't think we have any necessarily liability. What was that? Yeah, that's fine. We could look at it like that. How often does Consumer Reports get sued?
Hi, good morning. My question is along the lines of the liability, and I really think that this is great, and I think the work that you and other folks are doing, trying to test these monitors and get the information out, is very important. Just to give you a little story quickly. So there is a community group perhaps that maybe feels that their area isn't very clean, and they use one of these monitors that hasn't been tested by a facility like yours and cause real estate sales to go down. Now, information that you provide would help, I think, in a bigger, broader picture, and we do need something like that, that people can say, well, this isn't an indicator, something. I like the clearinghouse and the website, and I hope that that will help dissipate some of that type of I don't know what you call hysterical, I don't know what you call it. So that was.
I mean, that's the goal. That's a very common story, is that, you know, some data gets generated more frequently now with these types of instruments, and people start acting on it without knowing the quality of the data. I mean, there's definitely no QAP associated in most cases. But it's really lack of understanding of the sensor itself. And I'm not saying they don't work, but how good are they, and what are the interferences? And if you have a 1 second spike, is that something to panic over? Obviously not, but a community member doesn't know that, right? Yes?
Will you be doing field testing?
Yeah, so the idea is to first take the sensors and put them in the field next to traditional equipment. Because if they don't work in the field, there's no time. If you're getting garbage in the field, if you're getting noise, then we could save a lot of effort in going to the lab and trying to characterize them under different conditions, different levels, different interference, different temperatures and humidities. Because if these are being sold to work out of the box in the field, they should work in the field. But if they were getting anything decent in the field that looks like it's measuring something, we'll probably then we could bring it back to the lab and figure out what it is. And a lot of the manufacturers have done testing, but it's only been in the lab. And it's only been challenging their sensor with the one component it's designed to measure at very, very high levels. And they can do a little calibration curve way up here, and they have no idea how it works at lower levels. So it's getting better. The manufacturers are starting to understand a little bit of how we operate, but that's often all that's been done. If that, sometimes they buy a sensor, an AlphaSense sensor for $5 or something, and because it says it's going to measure SO2, they assume it measures SO2, period. Put it in a box, put some electronics around it, hook it up to a fancy website, done. Any other questions?
You know, one of the things I saw was some of the data is that over time, these sensors tend to drift off. They start off really nice, but as time goes on, they tend to drift off. And as they get cheaper, is kind of the idea is that you just toss them and buy a new one?
Yeah, and that's one approach. I've always had this idea for these sensors. If they're cheap enough, you can buy 30 of them and put them in a nice neighborhood scale study, you know, 200, 300 meters apart, and get that. I've always thought if they're really cheap enough, buy 30 of them and put them all in the same box. You have all your QA right there. You could do averaging. You can throw out the outliers. You can. I could probably get you an FEM now if we did something like that. But if it was cheap enough, right? So I think that's might be where we're headed. And then all you do is the 2 or 3 or 4 outliers that go out every month, go out and replace those, and now you have your 30 again. Makes a lot of sense to me. This one over here.
As these new units are being tested, is the data going to include the person hours that are consumed to operate, maintain, and repair these units?
Yeah, I think that's part of the work is going to be looking at ease of use and, you know, how much time it takes. Durability is a tough one because it takes us time, right? We need to put it out in the field for months and months and months and see what happens and how long it lasts. We can't always say, you know, we don't want to wait 3 years to publish data, so we don't want to say this is going to last 3 years, then you got to replace it. But no, part of maintenance, repair, you know, the amount of time it would take to deploy one of these is part of the mix of what we want to report, to the extent we can, obviously. They should be much less labor intensive than the type of equipment that we work with, just because there's not a lot of moving parts, and they're cheap enough that you're not going to buy a replacement part, you're going to buy a new one, right? You're going to have 10 on the shelf ready to go and just put the new one in. Yep.
Regarding calibrations and recalibration of this equipment, is there a frequency, you go by the manufacturer's expectations for as when this equipment is to be sent back for adjustment?
Well, right now, I doubt that any of with maybe some few exceptions, none of them even have any calibration associated with them whatsoever. They probably have a factory calibration, and that's it. A couple, I think, will take them back and test them if you send them back in. But part of what we're doing and part of what needs to be done is figuring out how frequently do they need to be calibrated and what does that calibration look like? And does it need to be like the full, 3-hour, 5-hour calibrations that we have to do, or can you just do a one-spot check at a station for a few minutes every now and then? Like, you want to keep these, these need to be useful, so you want to keep them very mobile, keep them going without a lot of effort, right? So there's going to have to be new ways of thinking about calibration, perhaps. One thought that a lot of people have had is that, because a lot of these may be personal, may be on your cell phone, whatever, is that if you're truly mobile and you're driving around, and then you're passing an air quality monitoring station, and it has, it has real-time data. Obviously, it's not QA'd, but real-time data for, say, ozone at that monitoring station, and you're driving by, it can know you're driving by and do that double check and give you a kind of an on-the-fly single-point calibration every time you're near a monitoring station. Well, it would compare. It would compare what the sensor's saying to what's at the monitoring station, and then maybe it could actually readjust the scale or the calibration on the sensor according to that. Right. That's an idea that's been thrown around quite a bit. How feasible it is, I don't know. We're not testing that procedure, but we need to look at these sensors and how often do they need to be calibrated, and can they hold a calibration, and for how long, and are they linear? We don't even know that. Most of them probably aren't linear.
Which of the criteria pollutants are they focusing on, and is there any that are not being focused on?
Okay, so they can do ozone reasonably well, but I'm not sure why you need personal ozone, so that's PM 2.5, a few years ago, they were pretty far off, but I just saw some data that Andrea sent me that looks pretty promising for one of them on PM 2.5. So I think that's getting pretty close to being usable. SO2, they can do reasonably well. There's some interference problems there, though. They have, for NOx and NO2, there's some things that work pretty well. There are interference problems. So they're working on an NO2 sensor with an ozone sensor to kind of subtract off the interferences, and they've made some progress there. I think it's not perfect yet. CO they can do reasonably well. Lead is obviously a tough one. I think I covered all the criteria pollutants there. Anything else? Okay, thank you for your time, and I hope you have a great training session the rest of the day. I'll hang around a little bit, but I'll probably have to leave around 11 o'clock, but thanks.